Okay, hello, this is problem 3. Um, so a couple of things I wanted to mention. This is actually kind of a common question on exams. And just to give some background here, I am not the person who writes the exams for this class. I am the instructor for this course, but since there's so many Math 241 courses, at Oregon State University, there's a coordinator, and that coordinator is the person who writes the exam for all of the students that take it that term. So, and in fact, these notes are that coordinator's notes. So he's taught this class for many years, and these are the notes that he uses. They're just like in my own font, basically. But he writes the exam, and I have taught this class with him for a long time. And I've noticed that in particular, part C is actually something that he uses a lot on tests. It's usually a multiple choice question, so that's something to keep in mind. And it's not on every test, so I won't know. In fact, you and I will find out at the same time. But I do think it's worth thinking about. Another thing is, so speaking of tests, so if you were on a test and you got this question, the first thing you should do is take a derivative of this. Like, you don't even have to read the problem to know that's a good idea. So I think we'll just do this on the side over here. So I want to do s prime of x, starting with this equation. The thing is, we know from the beginning that we don't actually need to even think about the derivative of 2.1. That's just 0. Derivative of a constant is 0. We've known that from like day 2. So I'm just taking a derivative of this next part. So I'm going to write that as 7 over x plus 1 squared, and I'm taking the derivative of that. To make it easier on myself, I'm going to move the x plus 1 squared to the top. So I want s prime of x, and that is going to equal 7 x plus 1 to the negative 2 power, and I'm taking the derivative. Since I'm taking the derivative, I can pull the 7 out. Constants very rarely matter, it turns out. And then I'm just taking the derivative of x plus 1 to the negative 2 power. That's all I'm worried about. So s prime of x is equal to 7 times, okay, so I've got x plus 1 to the negative 2 power. I'm going to bring the negative 2 down, and then I do x plus 1, so this is the general power rule, negative 2 minus 1, and then x plus 1, I need to take the derivative of that and multiply it out here. So derivative of x is 1, derivative of 1 is 0, so actually that's all I've got. And simplifying, I get negative 14 x plus 1 to the negative 3 power. So I'm going to put a circle around this because in this class, it's pretty important to take derivatives. So I haven't even read the problem, and I know I need to take a derivative because this is basically a class about differentiating. And on a test, if you took the derivative and you have no idea why, you'll probably get points. And that's okay. Just try taking the derivative if you don't know what to do. But let's read it now. Market analysis of a store's sales indicate that on the xth day of January, total sales in thousands of dollars can be modeled by the function s of x equals 2.17 plus 7 over x plus 1 squared. So, what does the model predict for sales on January 3rd? Okay, January 3rd, okay. Market sales indicate that on the X day of January, total sales. Okay, so it just takes me a second to get in here, but it looks like X is the day in January, which is 3. And we want to know the sales, so I will do S of 3, which is 2.1 plus 7 over 3 plus 1 squared. Okay, I'll put that in my calculator. 7 divided 3 plus 1 is 4. 4 squared is 64. I mean 16. Whew, that was pretty bad. 4 squared is 16, and I'm adding to that 2.1. And then, so there's a trick here though that I noticed when I read the problem, 2.5375. This is important. It's in thousands of dollars. So I would multiply this number by 1,000 for when I think about it, like what it means logically. So that number corresponds to $2,537.50. Okay, so I need to write my answer as a sentence. On January 3rd, the sales were $2,000, $2,537.50. So, I mean, I worded that kind of funny. Another way to say it would be on January 3rd, they sold $2,537.50 worth of stuff. Okay, next thing, at what rate are sales changing on January 3rd? Write your answer in a sentence. So this word here, rate, on day 2, I think we talked about how rate is a slope. Slope and rate are kind of connected. And since then, we've been talking about how slope and differentiability are connected. So this is the key word that tells you I want the derivative. So at what rate? I need the derivative. So, and I need that derivative on January 3rd. That tells me x equals 3. So I'm looking for s prime of 3. So s prime of 3, we did the work to find s prime, and like I told you, it's going to pay off. Taking your derivative is always a good idea. So s prime of 3 is going to be negative 14 times 3 plus 1 to the negative 3 power. That's something I can plug into a calculator. So 3 plus 1 is 4 to the negative 3 power, and then times negative 14. So, and then like before, everything we want to multiply by 1,000 because everything's in thousands of dollars. So this is what I got in my calculator, 0.21875, but I need to multiply everything by 1,000 to get like the real life scenario. So s prime of 3, we decided was 2,000, not 2,000, minus 218.75. So there's like a little chunk here that I want to talk about. So we need to know what the units are. So what I do is I think about how we're talking about a slope here. So it should be the output over the input, or like the y over the x. I don't know how you want to think about that, but the output is sales in dollars. So the units are dollars. And then the input was the x day. So this is days on the bottom. So now that I have the units, I can write my sentence. On January 3rd, the sales were changing oops, I wrote an S. The sales were changing by $218.75 per day. Okay, so got two pieces of information here. On January 3rd, the sales were $2,537.50. On that same day, the sales appeared to be changing by $218. Oh, and actually, I think it's a negative, yeah. So they were changing by negative $218.75 per day. So that means it's going down, decreasing. Phew. Okay, so now I'm going to use my results from parts A and B to estimate the sales on January 4th. So that's the next day. So I already know what they were on January 3rd, and I know how much they're changing. So I just put that together. So it started with $2,537.50, and I know it's going down by $218.75. So now I'm just going to subtract. So I'm doing that on my calculator. And that gives me $2,318.75. So that's my guess, but it's not exact. It's just kind of an estimation. Part C says, what does the model predict for sales on January 4th? So the model that we were given is up here. It's this guy right here. So I'll just plug it into there. Okay. So S of X equals 2.1. Oh man, I keep writing sevens. It's this weird thing I do. 2.1 plus 7 over x plus 1 squared. Right, okay, and I want to know on January 4th, so S of 4 equals 2.1 plus 7 over, so 4 plus 1 is 5 squared, and that's a calculator thing. 7 divided by 25 plus 2.1 is 2.38, and then everything I'm multiplying by 1,000. So that's 2,380. So the question says, how good was the estimate from part C? And I mean, I'd say it's a reasonable estimate. It looks like it's roughly 60 off. So it wasn't a terrible estimation. But it is a way we can use to estimate if we don't have the actual function to plug it in. So let me know if you have any questions. This is tough stuff, but we can do it.